Okay. So, circles. Is a circle a disc or a ring?
A ring.
A ring. A disc. A disc.
It's a disc.
Depends on how you view it, you know what I mean?
Which one is a circle?
The bubble. They actually are double bubble circles.
I think the double bubble
They're both
is incomplete.
No.
They're both wrong.
A circle is a ring. It is the set of all points. So this is really infinitely many dots. It's a set of all points that are the same distance from the same place. Guess what they're all the same distance from?
The middle.
The radius.
The center. And that distance is called the radius. Okay? And so a circle is a ring. You were taught when you were little that this disc was a circle. No. The red ring drawn on the edge of it is a circle. Everything inside it is just the stuff inside the circle. But only the red part is the actual circle.
We've been lied to.
You have been deceived. I know, because we love Blue's Clues in my house, and back in, there was a whole, we're searching for shapes. And they called this kind of thing a circle, but alas, this is just a circular object.
Is it a plane?
Okay? Only the red part
Does it go both ways?
is the ring. Okay? So that's a circle. Now, the important parts of a circle are all the points around the outside and the center. The important number in a circle is, what do you think? That radius.
Pi.
Well, pi shows up on its own and just causes trouble. Okay? So we'll get to pi in a minute, because I'm giving you a whole week off for Pi Day. Yeah, March 14th.
Open invite, Mark.
March 14th is Pi Day. Okay?
Oh, 3.14. 1.5.
Oh my God.
That's pi. Followed by.
Okay. Shh. So, the first thing we do is, this is something you're going to spend a lot of time doing next year in Algebra 2, which is taking shapes, putting them onto a coordinate grid, and seeing what you can learn from making algebra out of them. Okay? And something that was discovered a very long time ago is that if you have any point on a circle, oh look, here's a circle. Any point on here can be represented with a point x and y, can't it? So could this point over here have an x and a y coordinate?
Uh-huh.
And this guy down here could have an x and a y coordinate?
Yes, ma'am.
Okay. Now, the center of my circle happens to be on the origin. Where is the origin? What are the coordinates of the origin?
0, 0.
That's 0, 0. Well, the origin is specifically 0, 0. Okay? So if you have a circle with all these xy points, and its center is right at the origin, then the Pythagorean theorem shows up. Pythagorean theorem shows up. And you're like, what the heck? Circles, what do they have to do with the stinking right triangles? Well, this is pretty much all of trigonometry, by the way, so pre-cal, you're going to do this a lot. If I wanted to find xy, how high up is the x point? It's actually y up. I said that all wrong. The y coordinate is up y. I'm that smart. How far over is the x coordinate?
X.
It's x. And if I wanted to know the radius of this circle, could I figure it out?
Of course.
Yeah, because that x and that y make a right triangle.
A squared equals b squared.
So it'd be a squared plus b squared is c squared, but let's plug in these numbers.
All right.
So my first one would be what? X squared,
Equals
and then plus, and then what's the other leg?
y squared.
Y squared. And what would it equal?
R squared.
My radius is that hypotenuse. Okay? So the equation of a circle, when its center is at the origin, is literally x squared plus y squared always has to equal the square of the radius. Any point you pick on this circle, if you look at the x and the y down here, x squared plus y squared will equal the radius squared. Whatever these numbers are, square them and add them up and you'll get the square of the radius. Every time. Oh look! A circle! On the graph, find its center. Where's its center?
At the origin, miss.
It's at the origin! Oh my gosh! So the center is at 0, 0. Okay, cool. How big is its radius?
Well,
You don't know. Figure it out.
Well, can you figure it out by looking at the picture?
Yeah.
Yes, ma'am.
Yeah, go from the center out to an edge, and if you go perfectly horizontal or perfectly vertical, it'll be a nice pretty number, which is
3.
3. You can use these now to write your equation. If my center is at the origin, what should my equation look like?
X squared.
X squared plus y squared should equal, what's my r? 3, and it should be squared. And so then, of course, you have to simplify junk, right? And so that would be x squared plus y squared equals 9. That is the equation for that circle. And mathematicians do all sorts of disgusting stuff with that you don't really want to know about right now. All I'm going to ask you to do for this unit is be able to look at a picture and write that equation, or if I give you the equation, see if you can draw the circle. Think you can do that? So I'm sure you could.
Okay.
So down here, look at B down at the very bottom. It says the center is at 0, 0, and its radius is 2.5. Don't even draw anything. I want you to just write the standard equation for this circle on a graph. Write the equation this would make if you drew it on a graph.
Okay.
Remember, it's weird that the circle is going to use the Pythagorean theorem formula. So what's it going to look like?
X squared.
X squared
equals 2.
plus y squared equals 2.5. Oh, well, I need to know what 2, and it's 6.25.
6.2.
That's your equation. Think you can do that? Well, yeah, but that's when the center is at 0, 0, and as we know, zeros make everything simple, don't they?
Yes, ma'am.
But what if I picked up that circle and moved it?
You'd have to literally...
Something would have to change in my formula, huh? So, what if I move my center over? And so what if the center, instead of being at 0, 0, was at some letter H, whatever number that is, and some letter K? You did this with parabolas last year. The H and the K, you also did it with lines. The H and the K tell you where the center moves. Okay, good. So, look, so my equation, even if I move the circle, could I still draw a little right triangle from the center?
Yeah.
So my formula is still going to be something that looks like the Pythagorean theorem. And it's still going to have x in it, and it's still going to have y in it. But since I moved the origin from 0, 0, I'm going to have to tell how far everything moved. How far did my x move?
2.
It moved h. And so inside parentheses, the signs are always opposite. So I'm going to put x minus h. And then how far is my y moving when I move the center?
Minus K.
It's k, so it'll be minus k.
Wait, is there ever
Why does it have to be minus?
with add H or K?
Well, if you're using a negative number, if you subtract a negative, wouldn't it then turn positive? Okay. So, oh look, behold, an equation in standard circle form. What do you think the radius of this mystery circle is?
4.
It is not 16.
4.
Remember, this is r squared. So my plane R will be 4. Okay? And so then my center of my circle,
3, -1.
okay? And so you look here, what's with my X?
3.
It's a -3, but remember that's opposite of where the center really is. So where's your center really at?
3.
+3. And then for the Y, it says Y plus 1. So where is your center really?
-1.
It's at -1.
Little bit.
Just by looking at the equation, you can figure out where your circle is and how big it is.
All right.
All right? So try right below. Try these two. Try writing the equation for this guy A and this guy C. I'll give you a minute to get them both done. So for this guy, here's my X and my Y. That's where my center is. So it would be X minus 0 squared plus Y minus, but then it's a -9 squared. And then my radius is 4.2 squared. And so then, of course, a minus negative becomes a positive.
This is 4.2.
So it'll be, and X minus 0 is just X. So that's X squared plus Y plus 9 squared. And then what is 4.2 squared? Somebody who has a calculator, because I don't.
17.64.
17.64. So here is the first one. I just did it really quick. And notice all I did was I plugged in the X and the Y. Okay. And my sign, what is X minus nothing?
0.
No, X minus nothing is not nothing. It's plain old X. And so I simplified X minus 0 into just X. And then the parentheses were allowed to drop away. Here it was minus the -9, which is a +9. Notice my signs are opposite. The signs should always be opposite inside the parentheses from wherever it was. And then I had to square my radius to match my equation. Okay? Try C now.
I got it.
Can I get some water?
Yeah, go ahead.
Bye.
I'll give you a 10-second head start, and then I'm going to start writing it.
Oh boy. Already got it.
Some people are not writing, though, so either they're already done or they're going to just wait for me. Okay, so my center is at -2, 5. Those are my X and my Y. So it'll be X plus 2 squared plus Y plus 5 squared equals 49. Done. Did you get what I got?
Yeah. Wait.
Where did I screw up?
Wait, what did I
It should be opposite what it was up here. Didn't I ask you to tell me what the mistake was?
Yeah.
So that was me doing it on purpose so that y'all would look for it. That's an analytical thing I'm trying to teach you. So no, that was an on-purpose mistake, not just me.
Not everything's
Was
right.
it a rhetorical question?
No, it was just me wanting you to look for it. Okay?
There are bigger things than like this.
All right. Shh. But then, I make things really disgusting. And I give you something that looks like this, and I say the point -5, 6 is on a circle. Graph -5, 6. And it's somewhere like that. Okay? And where is the center of your circle?
-1, 3.
It's at -1, 3. Okay? So would you now sketch the circle? Since you know where the center is, how would you have to draw it? And it doesn't have to be perfect and beautiful, because it's not going to be. You don't have anything to make it perfect and beautiful. Okay? So everybody, you've sketched your circle?
No.
Well, sketch it then. Sketch where you think the circle is. 5, 6 should be on the circle, and the center should be -1, 3. Sketch what you think that should look like. And it's not going to be beautiful, and we're used to that, because I can't make it pretty either. Okay? And if I had to guess, you probably have something that looks, kind of like that, but oh, look, see, this side's way too fat, huh? So see? Yeah, it's a circle. Okay? Shh. Regardless of how it's drawn, Now, could you write the equation? Go.
Three circles, you know.
And you know where the center is? Okay, so then you know what goes in with your x and y's. Oh dear, what goes in for the x part?
X
X, then what?
plus 5.
Plus 1.
Yeah.
Why don't I use the 5?
Because that's the point on the circle.
Yeah, I need the center to go in here, not some random point on the circle. And so, I tried to deceive you, and a bunch of you fell for it. You just picked the first point I gave you. This formula, it's the center values that get put in your formula. And so then it'll be y with what?
Minus 3.
The minus 3. And then what do I need for the end? Radio.
We have to use the Pythagorean theorem.
I don't know the radius. Can I figure out the radius? Yeah, I can make a right triangle. How far across is that right triangle?
4.
How far up and down is that right triangle? And so since you know your Pythagorean triples, 3 squared plus 4 squared equals 5 squared, which is
25.
25. And there's your equation.
Yeah, we know.
Think you can do that? That's all I'm going to demand of you for this algebra E junk. Okay?
Algebra is
All right, cool. Now let's go to the front of your notes. Well, no, that was your day 0. Last year they had to take that home and learn that on their own. This is actually what we're trying to learn.
Major arc, minor arc.
And you're very excited.
So many arcs.
Of course, huh?
All right, so we're going to start off with, behold, a circle. What is a circle? It's a set of points. See, it's all these dots. All those dots are the circle. Every single one of them. It's a set of points that are all equidistant. They're all the same distance from where? Equidistant. From the center? Okay. What is that distance called?
Radius.
It's called the radius. Okay. Now, if I take 2 of those radii, okay.
No, that's not right, that's not right.
What the heck?
I took 2 radii. Remember, radii is plural for radius. Okay.
The circle.
Oh, look! My 2 radii formed what kind of figure here?
Not too strong.
Not a triangle, that's not a triangle.
An angle.
It's just an angle. Now, guess what? Since it's an angle whose vertex is the center of a circle, guess what kind of angle this is called?
Central angle.
It's a central angle. So it's an angle whose vertex is the center of a circle. And for circle, I'm too lazy to write circle, and so I draw a little circle with a dot in the middle for the center. And it looks like an eyeball staring at you. Give it eyelashes if you want, I don't
Why
care.
can't you just draw a circle?
Because then it looks like an O or a 0.
Well, couldn't you put like all the quotation or whatever it's called?
Or why don't I just draw this and say that's the symbol for a circle?
But then it's scary.
Even eyelashes.
Only if you're scared of eyeballs.
All right.
Okay? And go ahead and let's go ahead and remind ourselves that the sides of a central angle are radii.
I can do that.
Okay?
Follow the instructions. Sides.
Now, I could draw lots of central angles, couldn't I?
Yeah, radii.
Yeah, I could draw a bunch of them, but if you take
Radii.
if you take all the central angles in a circle that don't overlap and put them together, how many degrees can you make around that center?
360.
360. So the sum of your central angles equals 360 degrees. I know, your mind is blown. This is like new information to you for sure.
Yep.
You're very impressed.
Indeed.
Now the thing is central angles cut up your circle. This blue radius here, it cuts off the circle there, and it cuts off the circle there, and it leaves this little roundish thing. Okay? What is the name of this pink piece of a circle?
It's called all segment.
Keep it small.
Angle bisector? Arc.
Minor.
It's an arc. Okay? An arc is just a piece of a circle. So let's put that somewhere. Arc is a piece of a circle.
Shaking.
That's all it is. And you hear arc, and it just makes you think of a seal, right?
No.
You know, they go arc, 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 arc. Right?
Wait.
That's what I think of when I hear arc. I don't know how you were raised, but that's what I think.
I didn't tell you to do that.
And so, okay?
Did I tell you all the way?
Now, if an arc is a piece of a circle, is it the whole 360 degrees of the circle?
No.
No. So, the degree of that arc, how do I know how many degrees are in that arc?
By doing that.
By knowing the measure of the central angle. So the degree of an arc formed by the central angle is equal to the angle. So we're going to play like, I'm going to make up a number for this blue guy here. The formed by the central angle is, maybe I scribbled something out there, equal to the angle. So I'm going to say this angle right here is, I don't know, 117 degrees. I just picked a number. I like that number. Sounds good.
Good number.
Divides by 9. We like it. And then you go, okay, if that's the measure of that central angle, how many degrees are in this arc?
117.
It's going to be 117 degrees. The measure of the angle, we use that to determine what we're going to call the arc. Okay? And if I make this a smaller angle, you get a smaller arc. And if you stretch the angle around huge, you get a big arc.
Whoa.
And guess what? We have fancy math words for little arcs, big arcs, and medium-sized arcs.
Minor arc and major arc.
Minor arc, major arc, but instead of medium-sized arc, we call it a semicircle. Just hearing those three terms, I'll give candy to whoever can guess what makes a minor arc a minor arc. Oh, I've got some nice volunteers. Yes, go ahead.
If it's between angles 1 degree and 90 degrees.
If what is?
The angle.
The arc.
The arc. Minor arc.
If it's a...
1 and...
So it can't be a 0.7 degrees?
I got it.
Arc between 0 and
Little girl.
90.
So, nope.
0.
Yes, Sean.
An arc between 0 degrees and 180 degrees.
Yeah, so it's an arc. Why did I put arc? An arc formed by a central angle and is less than 180 degrees. It's technically also bigger than 0 degrees, but we're going to focus just on it being less than 180 degrees.
Get you some candy.
Yes, you get the candy. All right. I need another victim.
I got one.
Oh, I got some. Okay, Elliot, what do you think you got?
A major arc
What do you think the major arc is?
An angle that is more than 100.
It is not an angle. An arc is not an angle.
What?
An arc is an arc.
Literally?
No, I got it.
Arc bigger than 180 to 360.
Okay, so it's an arc formed by a central angle. I'll give you credit, but you're half wrong.
Yeah.
That is more than 180. They can technically be bigger than 360.
Literally?
You can wind around and around and around more than once. But I told you still get credit for that.
Is that going to be on the test?
No, we're not going to use any of the ones bigger than 360. Okay? But just so you know, when you get to trigonometry in pre-cal, you're going to be using 780-degree angles. Yeah.
Literally? Is that even literally?
Nuts. It's nuts. Shh. Okay, a last victim, a semicircle. Yes, Reese.
An arc where the central angle is 180 degrees.
An arc formed by, well, it's formed by a central angle, and the arc itself equals 180 degrees. The angle does as well, because the angle matches the arc. But the arc itself, we consider it being measuring 180 degrees. And so then we have to figure out how to name these fellers. And you name arcs the same way you named segments. What did you have to use to name a segment? Letters, points. Which points of the segment did you use to name it? The endpoints. Get candy.
Go get your piece of candy.
Okay. You used the endpoints to name a segment. Well, guess what you used to name an arc?
Arcs.
The same ding-dang thing. So you're going to also use your endpoints. So behold, this pink arc. What are its endpoints?
A, B.
A and B. So guess what we would, ouch, what kind of arc is this pink arc? It's a minor arc. Because it's less than 180. To name it, when it's a minor arc, you name with the two endpoints. So what would be the name of this pink arc?
AB.
You would call it arc AB, and to make sure you know it's an arc, instead of a segment on top, you put a little eyebrow, a little arc guy.
That is so cute.
That is so mad.
But wait, there's more. If you can name a segment in either direction, you can also name an arc in either direction. So what is the other name for this same arc?
BA.
It's BA. Arc BA.
Arc.
Name it ACB or BC.
No, because that ACB would be tracing the angle. And we don't want the angle, we want the arc, the curvy thing. Alright? You're all being recorded right now.
Yeah, that's what I knew that. I'll make sure you want to play that game?
Now, wait a minute, hold on, stop. Arc AB goes from A to B. But check this out. I'm going to make a different arc from A to B. I'm going to make an arc from A to B going this way.
Major arc.
Oh, that's a major.
How many degrees is that big green arc I just made?
200.
360 minus 1.
I would have to do 360.
I did that in my head.
It's 243?
Yes.
Okay, so that's a 243 degree angle, which means I have a 243 degree arc. If that green guy is 243, which kind of arc is it?
Major.
It's a major arc.
Major.
Major arc. Okay? Shh. Now, how am I going to name it? Because it went from A to B, but I already used the name AB for the pink guy.
BA.
Major A, B.
For a major arc, you always have to use 3 points.
Oh, AD.
So you make up another one or something?
If you don't have a third one, you have to make one up. But it has to be a point along that major path. So what is a point along this major path?
D.
D.
Oh, I didn't see that.
So I would call this green guy arc ADB. And the letters tell you what path to trace. 3 letters tells you to go the long way, the major arc way, and go through point D. If you just see 2 letters, it means go the shortest possible way, the minor arc direction. And you don't have to use one in between. Even if there is a point in between there, you don't have to use it. Okay? So, one last guy here. Wait, what would be another name for arc ADB? BDA. The letters tell you which way to trace.
How would it be if you're doing a semicircle?
Oh, it's an excellent question. Hold on. To draw a semicircle,
Half an eyebrow.
that's half a circle, right?
Yeah.
Which would be 180 degrees?
Yeah.
Notice that comes from what kind of angle? A straight angle. Did you know that a diameter is just a straight angle inside a circle?
Yeah.
Yeah. So it comes from that straight angle. So let's call this point down here E. And it's made of 2 radii. It's the distance of 2 radii. Okay? And so how many semicircles are formed by that particular
2.
2? So is 2 letters going to be enough to tell me which one I want? No. You're going to have to use 3 letters for a semicircle as well, because there is a semicircle on the right, and there is a semicircle on the left. Okay? So let me get a different color here. This dark blue. This semicircle on the left would be named what?
AE.
Just AE?
AD.
AD, because I have to tell you I want the one that goes through D to be the one on the left. So arc ADE. What's the other name for arc ADE? Arc ETA, okay. What about over here on the right now? So if I make this semicircle, what semicircle would that be? Arc what? Good old Abe?
Honestly.
What would be the other name for arc Abe? Eba. But you need that 3rd letter to tell you which side of the circle to go around. Okay? So the only time you can get away with 2 letters is if it's a minor arc. And you can just assume to go whichever way shortest. Okay? So remind me, how many degrees are in an entire circle?
360.
Don't leave it naked.
Degrees.
How many degrees are in minor arcs?
Less than 1.
Less than 180.
Degrees.
And degrees. I already had it written. What about major arcs?
180 degrees.
More than 180
Oh, wait,
degrees.
more than 180.
Okay? So what you're going to be asked to do, first of all, on your homework, I'll give you a picture with probably a crap ton of, there's a lot of angles on that. And I'm going to say, find the measures of each of these arcs, and then look, I tell you that RT is a diameter. How can you tell in the picture it was a diameter?
Because it goes from one side to the other.
Well, yeah, lots of things go from one side to the other.
Semicircle.
It goes through the center. See how the center is highlighted?
Yeah.
If you see that highlighted and you see a line going straight through it, that tells you it's a diameter. Okay? So go ahead and figure out these 3 guys. I know that the arc symbol is kind of pointy. It's the best thing we can do. Computers are evil. So just play along. Find those 3 arcs. I'll give you a minute or 2. Argue with each other.
What the heck was that?
Honestly.
So RS is going to be a minor arc going from R along the shorter distance to S. And oh look, it'll be the measure of that angle. So it'll be 110 degrees.
155 degrees.
For RST, I have to go from R through S to T. So I'm going to go from here to here. Well, that takes up that whole straight angle. So I know the whole thing has to be 180 degrees because the diameter is just a straight angle. Then for RTS, I have to start at R and go backwards from T to S. Now I know this semicircle is 180, and I know this semicircle was 180, so I can subtract and find that this little piece, 180 minus 110, is 70. And now to get this arc, I can combine these two angles and get 250 degrees. Now, compare! See if you have my degrees. Did you get the same thing as me?
Oh, I did it.
Shh!
I'm mad.
Okay. Can someone tell me how you found C? Raise your hand. Tell me how you found C. I'll give you candy if you can tell me what you did. Yeah.
360 minus 110.
That is one way to do it. Okay? So Chloe said, I know the whole circle is 360, and the only piece that's not red is this blue part, which is 110. So 360 minus the 110 gives me 250. That's one way to do it. What's a different, get candy, what's a different way?
180 plus 70.
Yeah, you could see that if this semicircle was 180 and this blue part was 110, then this red part here had to be 70. So when you combine it with the other semicircle, you get 250 that way. And it doesn't matter which way you do it. As long as you do it right, do it whatever way you want. Okay? So thinking back, do you remember back in the dark ages of like Unit 1, we talked about adjacent angles?
Yes.
How would you describe an adjacent angle to a 5-year-old?
Two lines intersecting.
All right, that 5-year-old won't know what you're saying.
They're right next to each other.
Yes.
They're right next to each other.
Two angles that are right next to each other. How do you tell they're right next to each other?
They share sides.
They share one of their sides. So these two angles here, the 117 and this other guy, they share that little blue line. Here, they share another line in between. So guess what adjacent arcs are? They're arcs that share an endpoint. So if you've got two arcs that happen to touch at a point, they're considered adjacent. They do not overlap. Okay? It's not, if they overlap at all, that's not adjacent, that's overlapping.
We have another angle.
Okay? And what did adjacent angles imply?
No.
Adjacent angles implied
Angle addition postulate.
the angle addition postulate, which means you could add the angles up, right? So what do adjacent arcs imply?
Arc addition postulate.
The arc addition postulate, another AAP. Okay? And for arc addition, all it means is if you have an arc, let's pick an arc in this picture. What's an arc?
AB.
AB, y'all are boring.
Thank you.
So AB, so if I have, look what I'm going to do. If I have the measure of arc AB, if I know how big it is, what is an adjacent arc to AB?
BD.
I could do BD because it shares point B. What would be another adjacent arc?
AD.
AD. Let's do AD. It's adjacent because it shares this point. If I knew the measure of arc AD, and I decided to add those two numbers together, what measure would they end up being the same as?
DAB. It'll be
It'd be an arc.
DAD.
DAB. So it'd be the measure of arc DAB. What's the other name we could call that one?
Dab.
Bad.
Oh, that's what I
Okay.
What was that?
So the measures of the little guys add up to the big guy, which is shocking to you, I know. But notice you have to put the M there, because you're talking about their measures, whatever their numbers are. And a lot of you forget to put the M's on your angles. Please don't forget to put them on the arcs. Okay? So looking at this picture, I want you to identify each of these arcs as major, minor, or semicircle. And let's go. What is TQ?
Minor.
Minor.
Minor. Okay, if it's minor, what is the measure of arc TQ?
120.
120 degrees. Okay, that's not so bad. Okay, what about QS? Oh, I don't know QS. Well, what's another one? Oh, TS isn't bad. TS. Is TS major or minor or semi?
Minor.
It's another minor. And what is the measure of arc TS?
80.
It's 80 degrees. What will be TQR? So going from T
That'd be semi-circle.
past Q to R.
That'd be semi.
How do you know it's a semi?
Because 120 plus 60 is 180.
These add to 180, and 180 degrees makes a semicircle. And so the measure of arc TQR was found first. And we used that to name it. Okay? What about quirt? Arc quirt. There was actually a street in my town growing up named Quirt.
That's
Oh, I don't know how big Quirt is.
that's wrong.
Oh dear, how am I going to figure it out? I need this arc right here.
100 degrees.
I would love to add the three pieces, but I don't know this central piece.
100 degrees.
Oh, where are you getting 100 degrees from?
You add them up and subtract.
I don't know this angle.
No, you add 80,
You add all
120,
three, then
and
minus
60.
360.
Hold on. I'm trying to get Q through R to T. So I have 60 and 80, but I don't know how big that one is.
100.
How do you know that?
Because I added the other three.
Oh, did you use the whole circle to figure that one out?
I did.
Yeah, if you did 360 and subtracted all the other pieces you knew,
Yeah.
can you figure out Mystery God?
Yes.
Yeah, and it's how big?
100
100.
degrees.
So now how big is Quirt?
180. Wait.
No, it is 240.
It's 240 degrees, which makes it what kind of arc?
It's a major.
That's a major.
Wait, also, if you already know that TQR is 180, then you can just subtract 80 from 180.
Yes, you could have done it lots of different ways. Okay? Okay, what about QS?
160.
QS is this guy. Is that a major or a minor?
That's a minor.
It's still a minor. It's still less than half a circle.
Still
Okay? And what about RST? So R through S to T.
I don't wish I could.
180.
It's 180, which makes it what kind of arc? It's a semicircle. Not so bad. Think you
I
good?
thought I left my,
Okay.
I'm checking it, this one's my phone, it was in my spot, and it has the same.
Okay. Is it unlocking for you?
It's, well, it has to restart.
It's restarting.
I have it turned off.
Good, I'm glad it's, okay. But if it opens up for you, don't walk out until you can get it restarted, okay? Until you can tell me it's good, good. Okay, turn the page.
There's more.
You haven't suffered enough yet.
What? Hey, I didn't tell you to do that.
I tell you wrong.
Hey. Get back here. No.
Doesn't say, he doesn't say anything.
Silence there.
Okay. So I have drawn two circles, and they have the same center. I know they're not very good circles, but they have the same center. There's a fancy math word for two circles that have the same center, and no, it is not a target.
Oh, circumcision.
No, that's something that we did with
I
triangles.
think you know.
It's the,
Oh, my leg.
They are concentric circles.
I won't do it.
Okay? And you don't have to know that word right now. But the thing you have to know is, if I drew a central angle out of there, and told you that the measure of that angle was 60 degrees. Okay? And I'm just making up numbers. How big is this purple arc going to be?
60.
It's 60, okay, 60 degrees. And how big is this pink arc?
60 degrees.
It's also 60 degrees. They are both the same number of degrees out of your circle. Okay? But are they the same length? No. And anybody who's ever been in marching band knows this, because if you've had to be on the outside edge of a marching line that goes in a circle, you know, the further you're out from the center, the faster you have to walk to keep up.
Hashtag band.
Okay. So, arc measure is saying a number of degrees around. And that doesn't matter how big your circle is at all. Big pink circle, little purple circle, both had the same number of degrees. Okay? Arc length is do you guys need to leave until you can figure out how to behave appropriately in a classroom? Because I know third graders who know not to do that. Okay. Arc length is literally how long an arc is. Okay. But we have a fancy math definition for that. And so come down here to where it says arc length, and arc length is the length of a piece, that's an E, of a circle's circumference. What's a circumference?
The perimeter of a circle.
It's the perimeter of a circle. So an arc length is just a piece of the perimeter. Okay? And we have a formula for the whole circumference that you get to memorize. What does C equals pi d mean?
Pi times diameter.
Pi times your diameter. What if I don't know my diameter?
You can figure it out.
2 radii.
Oh, I could use 2 radii instead?
You could.
So either of these formulas would work. Now, these would find my whole circumference. Do they find partial circumferences?
No.
No. This is where these two things work together. If I want to know how long an arc is, I first figure out what its arc measure was. Okay? And so down here, I'm going to color one of these arcs red. I'm going to color this guy red. And I want to find the length of arc AB. Okay? And so the first thing I'm going to do is find the measure of the arc. And so what is the measure of that arc? It's 60 degrees. Is that my whole distance around the whole circle, or just a part?
Part.
Part. That's the measure of just an arc. It's out of how much is the whole circle? 360. So that arc is 60 out of 360. It's 1/6 of a circle. Okay. Well, then I go, that's part out of the whole thing, right? Well, then I make a proportion.
No.
Oh, so I did the measure of the arc out of the 360 degrees. And I say, okay, I need to know the arc's length. Do I know my arc's length? Nope. But what could I know? I could know the whole circumference. Can I figure out my whole circumference of this circle? Wouldn't the length of the arc just be 1/6 of that?
Yep.
So let's find the whole circumference. What formula do you want to use? The D formula or the R formula?
The R.
The R formula, because we've got our R. So it'll be 2 times pi times 8. And yes, you do have to memorize that one. And so what will my circumference be?
We're still recording.
Yeah. Still recording. The screen's on. So how big is the circumference?
50.3.
Hold on. Shh. First of all, what's 2 times 8?
16.
So it's 16 pi's. Now, pi is what's called a transcendental number. It goes on forever and it never repeats, and it's really obnoxious. And so I'm okay with you leaving your answer in terms of pi. So you could just say 16 pi's is the distance around that circle. If you were to make a decimal, you would be rounding it. And so it would be approximate. What is 16 pi approximately?
50.2.
How did you get that?
Calculator.
Yeah, do you know where pi is on your calculator?
Right there.
It's
It's the 8.
So the little caret above your division sign, it's the second button above that. And it comes out to be how much? 50.27 junk. Oh, you guys, this would only be half right. What would be wrong about it? Oh, is this a degrees? This is a circumference.
You need centimeters.
So this would be a length. This circumference is 50 point junk centimeters. Pay attention to what you're finding. Circumference is just a perimeter, a distance around. How far you walk to go around the circle. So I'm going to just stick with the 16 pi because I'm lazy. I'm going to come over here and say I didn't know how big my arc was, but I know it's a piece out of my 16 pi. Well, oh gee, how am I ever going to find x in this proportion?
We learned how to do this.
Oh, last unit, what did we do? Cross multiply. Now, I could cross multiply with the big fraction, or could I simplify it and use the little fraction?
Probably use the little fraction.
So I go, okay, I need 6 times x. That's 6 x's. What's 1 times 16 pi's?
16 pi.
Boy, that was killer. Now I need x by itself, so let's divide off the 6. And x comes out to be 16 pi's over 6.
Yep.
What would be wrong with that? 2 things. It needs to be simplified. These both divide by 2. So it'd be 8 pi over 3. Yes, you can leave it in terms of pi unless I tell you to give me a decimal. Okay? What else would be wrong with this? It's naked. What was I finding here?
Centimeter.
The length of an arc. And what are my lengths being measured in? Centimeters. Somebody with a calculator, approximately how many centimeters is 8 pi over 3?
8.378.
It's about 8.4 something or other centimeters. Okay? So all you have to do is think, if I need an arc, I need to make a fraction, because it's a fraction of my circle. It's just a piece of my circle. Okay? How are we going to do this guy? I want to find the measure of this arc.
Measure the arc.
How could I name that arc?
You can do LM.
Could I call this red arc LM? No. So what do?
You have to create a
I have to create a point on the arc. So pick a point anywhere and let's call it P. And so the measure of my arc, and how would I name it?
LPM.
LPM would work,
Did you use water?
would equal, and how big is arc LPM?
270 degrees.
It's 270 degrees. So I have found the measure of the arc. length of arc LPM?
No.
Yeah. What did they tell me it was?
61.2.
It's 61.26 meters. Don't leave it naked. What's it want me to find then? Read the words. It wants the whole circumference now. And they didn't tell me the radius. Can you do it?
You just there's 4 parts.
Yeah, we're still going to do the same thing, but we're going to go backwards. Do I know what fraction of the circle makes this red arc?
3/4.
It's 270 out of how many? 360. Guess what that simplifies down to, by the way? 3/4. So I have 3/4 of my circle. So this is part over whole. Do I know my part length or my whole circumference? I know the part length, the length of my arc. How big is it? 61.26 out of my whole circumference. Do I know my whole circumference?
No.
No.
It's X.
Call it X, sure. Could you call it C for circumference?
Yeah.
Could you call it B for Billy?
Yeah.
If you felt like it. And so then, we can find the whole circumference now. So you have calculators in front of you. This one has decimals, so you're going to find a decimal. 3x is going to equal whatever.
245.04.
Thank you, 245.04. And how much is x?
81.68.
It's 81.68. What is that?
That is...
It is the circumference. And what units shall it use? Meters. Okay?
Sectors.
Last part works the exact same way. But now instead of finding the length of an arc, we're going to do area.
Oh my God. Are you serious right now?
What does area measure?
The amount inside.
What amount of what inside? The amount of squids?
Mass.
Meter squared.
It's actually, area is the number of squares that fit inside something. Well, do squares fit very well in a circle? No, you're probably going to get some ugly decimal, right?
Yeah.
That's where pi comes from. From the fact that it never comes out pretty is why pi is as disgusting as it is.
What justifies how big the squares are?
Because it never comes out pretty.
You decide if you want them to be centimeter squares, or inch squares, or mile squares, or furlong squares, or whatever squares. Okay? And the formula is pi r squared because we're counting squares. I know you're shocked. I always got a kick out of that because, you know, it says the formula is pi r squared, but pi r round. And on pi day, you need to go and eat some pie.
Pi square.
Okay? Now, what if I just want a piece of my pie? Is that the area of my whole circle?
No.
No. Shh. So if you have a piece of a circle's area that's contained by a central angle, it gets a fancy math name. It's called a sector. And when you grow up, you're going to hear about different sectors of the workforce and stuff like that because people like to use pie graphs to do stuff. And so you'll often use sectors and things when you're in statistics and you're doing pie graphs. It's very exciting. For now, all you have to know that a sector is an area. It's a piece of the area of a circle. So arc length is measuring how long the crust is, and a sector is how much pizza you get. Okay? And you do it the same way you did the arc length. If I just have a piece of the circle, I know that the area of my sector is a piece of the area of the whole circle. And it just so happens that the measure of your arc at the edge of that sector, okay, helps you do that because it's out of 360 degrees. So if you know what fraction of the circle you have, you can figure out how much of the area you have. If you have half the circle, you're going to have half the area. If you have a quarter circle, you're going to get a quarter of the area. How many pieces do they cut pizzas into usually?
8.
Usually 8, unless it's like extra large. And each of those would have a sector that's theoretically an eighth the area of the whole thing. Okay? So, find the area of circle D, this whole circle. What's your formula? Pi r squared, even though they're round. So it'll be pi times, ooh, what is the radius of this guy? 14. Is the pi getting squared or just the radius? Just the radius. And you'll, of course, memorize 14 squared, right?
Of course. It's 144.
Sorry.
196.
It's 196 pies.
Quitting math.
And, of course, we don't want to leave it naked. It's an area, so it's a number of squares. What kind of squares do we have here? Feet squares. So that's the area of the whole circle. Now I'm going to color a sector of it red. Find the area of the red piece. Go.
120. Oh.
No, that's the measure. So the measure of that arc, it's 120 degrees out of the 360, which I know simplifies to 1/3. And that better equal my part area over my whole area, which was 196 pi. And so to solve this, I can just cross multiply. So 3x will equal 196 pi, and x will equal, and it's going to be a fraction, 196 pi over 3, which does not simplify, sadly, so I can just leave it as that, or I can approximate it at 205.25, and you don't want to leave it naked, so it'll be square feet. So here's my work for it. I highly recommend that you memorize that 120 is 1/3 of 360. How much is 2/3 of the 360? 240. I also recommend you memorize the quarters. 90, 180, 270, and 360. It's just handy to not have to be thinking so hard all the time.
What about the 8?
45, 90, 105, all that stuff. Okay? So, shh. How many of you got the 205 point junk square feet? Let's see if you set it up the way I did. I said that I had 120 degrees out of 360, which I simplified to 1/3, and then said my part is going to be out of 196 pies, because that's what I found up here. And then I cross-multiplied and simplified down to 205.25 square feet. That's an approximate version. If you left it in terms of pi, that's fine. Just don't leave it naked. Okay? So you've got the remaining time in class now to practice different pieces of this.
Yeah.